This is a quick video about an axial flux alternator I'm building right now. Starting out with these steel discs that are 5-inch diameter. They're 1/8 inch thick, and for all the magnets I'm going to be playing with on this platform, 1/8 of an inch is enough. In this case, I'm loading it up with 8 1-inch diameter by 1/4 inch thick neodymium magnets, N42 grade. And you can see this, it's thick enough because this is not magnetic on the back. So this could be either a dual rotor machine or a single rotor machine. It could be set up with either 4 or 8 magnets, depending on how much power you want at how much RPM. In this case, I 3D printed this piece to hold the bearings in each side. So this can just slip on a shaft or a bolt, and that's the idea here, to keep that simple. The magnets around here are alternating, so it'd be like north-south, as with all axial flux machines. In this video, I just wanted to show the options. This could be a single rotor machine, in which case these are, I forget how thick, 1/4 inch thick, I think they are. But to give an example, the middle of the coil will probably be at about this surface, about 1/4 of an inch away. Voltage is directly related to flux density, which we can measure in Gauss. So this will show Gauss. It's a Gauss meter. So I can measure that up here. And in this case, if I'm right over the top of the magnet, I can see about 1600 Gauss. So as a single rotor machine, that's the average of what the coil would see. Of course, at the surface, we'd have quite a bit more, 3200. But out here, at 1/2 inch away, it drops off dramatically. So the average will be about 1600 that the windings will be dealing with. The other option we could do to increase voltage would be just to add a second blank rotor with no magnets at all on it. So I'll put that on here and measure it real quick. So now I've put the 2 rotors together. On this side we just have a piece of blank steel. And I'll do the same test over this piece of plastic, which is actually part of my coil winder. Let me get it in here without breaking my meter. So if I probe around in here now, at that same height, seems like I can get up to about, so that'd be right over the magnet, about 2150. So it's about a 25% increase in flux in this case. It'd be more if I narrowed this air gap a little bit. I've been a bit generous with it. I could probably get 50% more if even a difference of 1/8 of an inch would be dramatic in this situation. But it is still quite an improvement just to run a blank rotor. If I ran another rotor like this that was also loaded with magnets, I would double it. So instead of seeing 1600, I would see 3200 at that same distance, or thereabouts. So anyhow, I'm going to continue building this and get round to winding some coils. When I do wind coils for this, the coils will be round. They'll have a hole in them the same size as the magnet because the flux goes through the coil. The windings couple the flux. lots of options here with these magnets. If I loaded this up with 4 magnets only, that would still be a good alternator. And I could put 4 pretty big coils in them. I could wind them out 1-inch inner diameter, and the outer diameter could come right up against this part, the hub. So that would be a good single phase configuration, 4 magnets and 4 big coils. Alternatively, with 3-phase, I could do 4 magnets and 3 big coils. In that case, I'd get a bit less power because the coils would be the same size. Actually, it might be about the same power and lower resistance overall, but the other alternative is load it with 8 magnets. In that case, I'll be winding for single phase either 4 big coils or 8 smaller coils. And the coils could only not have a lot of copper in them, so it wouldn't be an ideal configuration for single phase really. But for 3-phase, I could put 6 round coils in here, and they could be pretty big. And that would be probably the most powerful way to use this alternator. If I want the best bang for the buck out of this platform, it would be 3-phase with 6 coils, I believe. I'll wind some coils and we'll see what happens. Anyhow, just having fun in the shop. I look forward to getting this one built. In this case, the blade is going to bolt right onto the hub, and it should be a very simple machine to build and very free spinning, and we'll see.